Hey everybody, how's it going? I'm Corey. I go by CoreyJA on the internet. You can find me at CoreyJA.com. And today we're going to do some Advent of Code. We've been doing these Advent of Code puzzles. So Advent of Code are small programming puzzles that come out every day of December up until the 25th. And you can solve them in any language. And today we're going to be doing day 7 of Advent of Code in Rust. So let's dive right into the problem and then we'll dive into our code. So day 7, Camel Cards. Your all-expense-paid trip turns out to be a one-way, 5-minute ride in an airship. At least it's a cool airship. It drops you off at the edge of a vast desert and descends back to Island. Did you bring the parts? You turn around to see an elf completely covered in white clothing, wearing gloves and riding a large camel. Did you bring the parts? She asks again, louder this time. You aren't sure what parts she's looking for. You're here to figure out why the sand stopped. The parts! For the sand! Yes! Come with me, I will show you. She beckons you onto the camel. After riding a bit across the sands of Desert Island, you can see what look like large rocks covering half of the horizon. The elf explains that the rocks are all along the part of Desert Island that is directly above Island, making it hard to even get there. Normally, they use a big machine to move the rocks and filter the sand. But the machines have broken down because Desert Island recently stopped receiving the parts they need to fix the machines. You've already assumed it'll be your job to help figure out why the parts stopped when she asks you if you can help. You agree automatically. Because the journey will take a few days, she offers to teach you the game of Camel Cards. Camel Cards is sort of similar to poker, except it's designed to be easier to play while riding a camel. Perfect. In Camel Cards, you get a list of hands, and your goal is to order them based on the strength of each hand. A hand consists of 5 cards labeled Ace, King, Queen, Jack, 10, 9, 8, 7, 6, 5, 4, 3, 2. The relative strength of each card follows this order. Ace is the highest and 2 is the lowest, so aces are high. Each hand is exactly one type, from strongest to weakest. It could be a 4 of a kind, when all 5 of a kind, when they all have the same, when you have 5 aces, a 4 of a kind, when there's 4 of the same, a full house, where you have 3 and 2, a 3 of a kind, where you have 3 cards of the same label, a 2 pair, where 2 cards share, so there's two pairs, yep, there's 2s and 3s are pairs, 1 pair, where there's only 1 pair of numbers, and high card, where everything's different, and you just get credit for the high card. Hands are primarily ordered based on type. For example, every full house is stronger than any 3 of a kind. Yep. If 2 hands have the same type, a second ordering rule takes effect. Start by comparing the first card in each hand. If these cards are different, the hand with a stronger first card is considered stronger. Okay, so this is a bit different than poker. Like in poker, if it was 2 high cards, the higher high card would win. If these cards are different, the hand with the stronger first card is considered stronger. If the first card have the same label, then move on to considering the second card. If they differ, the hand with the higher second card wins. Otherwise, continue with the third card in each hand, then the fourth, then the fifth. So these things are both 4 of a kinds, but 3-3-3-3-2 is stronger because its first card is stronger. So it doesn't matter that we have that the thing that's matching is stronger. It's because the first card is stronger. And then these are both full houses, but this one is stronger because it has the 8 first, where this one has the 7. To play Camel Cards, you are given a list of hands and their corresponding bid, your puzzle input. This example shows 5 hands. Each hand is followed by its bid amount. Each hand wins an amount equal to its bid multiplied by its rank, where the weakest hand gets rank 1, the second weakest hand gets rank 2, and so on, up to the strongest hand. Because there are 5 hands in this example, the strongest hand will have rank 5 and its bid will be multiplied by 5. So the first step is to put the hands in order of strength. Okay, so you order them, and then you get their rank. Then you have to determine the total winnings of this set of hands by adding up the result of multiplying each hand's bid with its rank. So you just do the multiplication and sum it up for total winnings. Find the rank of every hand in your set. What are the total winnings? Perfect. Okay, so we have to do the ordering, multiply by the bid, and find the rank. So it's basically just all about ordering these hands. And So let's get started. We have a little bit of a parsing thing. We'll parse into something that can know all of these different values, and then also the bid. Okay, but before we do any of that, we got to make a new cargo binary in our workspace. So it's 06, and I think it's called Camel Cards. One was easy to remember the name of. Camel Cards. Man, having trouble typing. I feel like I always have trouble typing these at the very beginning. Oh, this isn't 6. This was supposed to be 7. That's okay. We'll change it to 7. And then in my cargo toml here. Nope, not that one. The top level one. There we go. I can add my 07 Camel Cards. Camel Cards. Okay. CD into 07 and cargo run, and we are off to the races here. So let's sketch out the basic thing that we're going to want to do. So let sample input, let sample part 1 answer, debug sample part 1 answer, and then lots of these things don't exist. So let's add the sample input first. New file, sample.input. Perfect. That knows what that is now. And then let's make our part 1. I actually want it on top. I like having main at the bottom here. So we take in a string and we output a U64, a nice big number here. And I think the first thing that we're going to want to do is define all the structs. So we have a hand, maybe? We have a struct that's a hand. And this has cards, which is a card, and there's 5 of these. Yep, length 5. And we have a bid, which we'll just make a U64 here, because that's the number type we're using. And let's make I think our card is actually going to be an enum, and it's not those at all. It's ace, king, queen, jack, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Oh man, 2, 1. Come on. Oh, why didn't you do that one, Copilot? You couldn't get the last one for me? So silly. Okay. So let's implement some parses, and I'm actually going to do it in the opposite order. I'm going to implement card first. So impl, and actually I'm going to do something different. I'm going to, on card, I'm going to do impl from character for card. And just, oops. Implement the missing members. So I'm going to just do a little different than parse, because we have a specific type character that this can come from. And I just wanted to do it a little differently today. I don't know why. But let's match on self. I kind of want Copilot just to do this for me, like that. Perfect. Ace, king, queen, jack, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Perfect. And then invalid if we get something different. Love it. Okay, so now we can impl a method on our hand, and we're going to write function parse is something like that. No, I don't think we are gonna do that. So we're gonna split on white space. Let split equals input.split white space. Let's collect it to a vec, I guess. Let cards equals split at 0. Let bid split at 1. Let bid equals bid dot parse. Unwrap. Nice. Not sure why it thinks that. Why is it not mad about the types here at all? Oh, because I just have a syntax error somewhere, I think. Expected right curly. Okay. So what did I do that doesn't have a curly brace where it should? And is throwing everything off. Is it in this? Yes, it is. There we go. Expected value found module self. Oh, from value. I didn't read how that worked. From character. Okay, perfect. Yep, so then we want let cards equal cards dot characters dot from the character, and we get our cards. Oh. Can I collect to an array? Can't be built directly from an iter. Yeah. Can I collect it to a vec? And then can I take the vec to an iter? Let cards equal cards dot to array? I don't think so. Rust vec to array. I don't think that's an easy thing to do. Oh, I can try into, maybe. Try into dot unwrap. I know this is 5. Card doesn't implement debug. Oh, it can implement debug. Derive debug for hand and for, oops, card. Whoa, and for card. There we go. We collect that to a vec and then try converting it into an array, and it's gonna fit because we know there are only 5 characters. Okay, so now I can just, do I want to struct for my input? I don't know, let's do it. Struct for our input. It has some hands. It's a vec of hand. Impl for input. Function parse. Takes an input, returns a self. You just do it. You go over the lines, you parse each hand, collect to a vec. Love it. I'm gonna say just collect because it knows to be a vec because that's what the hands type is. I like that. Let input equals parsing it. And then yeah, we can debug it out just to see what it does. But oh, input doesn't implement debug. We can fix that. Derive debug. Nice, everything looks like a parsed. Let's actually look at them. Queen, 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 jack, ace, 483. Queen, 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 jack, ace, 483. Perfect. Awesome. Okay, so now I think we need to implement the score, like the type. So like hand type or something. So I think I want to make an enum out of this as well for the different types here. Let's put it up here. So we want an enum for hand type. And it's gonna be that, but in the opposite order. So it's 5 of a kind, and then 4 of a kind, and then full house, 3 of a kind, 2 pair, 1 pair, high card. Love that. And then we're gonna make another method on our hand that says function hand type. And yeah, so now we need to actually do the implementation here. So if self dot cards dot iter dot all well, I can't, I guess I could do let first card. Oh, I can just use the first one because I know what it is. So all card equals self dot cards at 0. If they all do that, so then we can return a 5 of a kind. And so the thing is that I can't do the equal on card because I haven't said that they are partial equals. And now we have one of these is a reference and the other And actually, I think actually I can get away with this if I do clone and copy. Because we can just copy cards willy-nilly, and that's fine. Oh yeah, because this doesn't return anything. That's okay though. We'll make it a to-do so it can return stuff later. Awesome. Okay, so 5 of a kind is handled. 4 of a kind, where 4 cards have the same label and 1 card has a different label. So maybe what I actually want to do here is like count the occurrences, because then I can get the 4 of a kind, 5 of a kind. Actually, yeah, lots of these are about that. Okay, so I want to count the number of each type I have, right? So we're gonna do this with just the standard library stuff. There's an awesome Rust package called itertools that has some really nifty iterator things that I think would just be able to solve this for me. But I'm gonna do it more manually. So I'm gonna do let count card counts equal a hash map. Yep, and it's a hash map of card to usize. Awesome. Okay, so then for C in self.cards, card count dot entry for C. What's this error? Oh, because card doesn't have equal and hash. Okay. Let's do that. So it has partial equals, but now it needs equals and hash to be used as a cache key. And we got to make this mutable because we're putting things in it. And modify or insert 1. Yeah, okay. So if there's an entry, we add 1 to it. If there wasn't an entry, we just insert 1. Yeah, no, I think I might have written this differently. I would have done or default plus equals 1. Can't be applied. Might have written it like that, but I actually kind of like theirs better. I like and modify or insert. That just feels like a better like words of what I'm doing. So now we want to do if card count dot length is 1. Yeah, if there's only 1 card, it's a 5 of a kind. If card count dot values dot any, that's 4. It's 4 of a kind. If card count dot values, wait, there contains value? No, there's contains key. Okay, that's fine. Values dot any equals 3. Oh, and there's one that's 2. Then it's a full house. Perfect. Love this. Yeah, so it's really just doing card counts. And then if there's any 3, we do 3 of a kind. If there's, oh yeah, if there's two twos, there's a 2 pair. Yep, I almost forgot about 2 pair. And then if there's only 1 pair, we do 1 pair. And if there's nothing, we just do high card. Cool. That was nice and easy, but it's never used, but that's okay. I think what I want to do is be able to make hands orderable. So I want to do implement partial order for hand. And then I want to implement the missing member. So we have to implement can't compare hand. The trait partial equals is not implemented for hand. Oh, okay. Well, we can implement partial equals for sure. We can also implement clone. I'm not sure we want copy, but it shouldn't matter. And we don't really care about that at all. So this is going to be a little bit of a weird partial order. I'm not going to look at bid at all. We're just going to compare cards. And do cards. Okay, we haven't done that yet either. That's okay. We're also going to have to make card implement order, but that one's really awesome. And it's going to be really easy to do that on the enum, and it's going to be great. Oh, and the same for hand type. Okay, cool. So what we want to do here is, why is it an option? Oh, because we might not be able to compare. Okay, cool. So we can compare almost all the time. So self dot hand type dot compare to the other hand type. Oh, that's what we're missing. And then it's telling me that compare doesn't exist for hand, which makes sense because it doesn't, or for hand type. But we can fix that by adding some derives up here. Partial equal, that one works. Let's also do equal. Let's do clone and copy because they're there, but I also really want partial order and order. Since we're just implementing these on an enum, they're going to be orderable in this order. So like, oh, wait a sec. Does that mean that I actually have these kind of reversed and high card? Yeah, if I want things that, if I want, right now I think high card is going to be the best because it has 6. Like, so assuming higher numbers better. So I think I want to reverse these. One pair, 2 pair, 3 of a kind, full house, 4 of a kind, 5 of a kind. Yeah. And then these are also going to be reverse the order. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King, Ace. Awesome. We're going to do the same thing here. We're going to implement, whoa. We're going to implement partial order and order. Now back up here, we can compare our hand type to the other hand type. And then we want to do then with. Is that a thing we can do? Wait, what is then with on? It is on an ordering and returns an ordering. Perfect. Awesome. But the then with is not going to be on bid. It's going to be self dot cards dot compare with other cards. Perfect. Because we want to do it in order. So like if the first one's different, then the second one's different, and that should be just what comparing the arrays by default is. So I think we can compare hands all the way now. So we should be pretty good for what we need to do here. So we can do let ordered hands equal input.hands iter sorted. Is that from iter tools? It might be, but hands here is a vector, so I can just make this mutable and then do input.hands.sort. Hand isn't orderable. I think it is though. Oh, but it implements partial order but not order. Can I just oh, and it needs to be equals to also have order implemented. You're deriving ord but have implemented it explicitly. Okay, that's okay. Oh, do I just want to implement order and compare and stop returning a sum here? Can't compare hand with hand. Partial order is not implemented. Oh, okay. So I want that. And then what do I do? Impl order ord for hand. Just like that. No, you want me to do it the other way, which is fine, but like stop. So what it wants me to do is it wants me to implement order, and then use that to implement partial order. No, then with. Just do it. Yay! Okay, awesome. So now I can sort the hands, and then I can do let mutable total equals 0. I can do, actually I don't need the total because I can just do this with iterary things. Input.hands.iter.enumerate .map. Not quite. I and then hand. Okay, so we want to do 5 minus I, right? Let multiplier equals 6, no, 5 minus I because 1 is going to be 0. And then what we want to map here is hand.bid times multiplier. Let's not do it as a U64 and just see what the type is. It's going to found U size. Okay. Change in a word. U size. Easy enough. U size. Everything happy? Everything's happy. Awesome. Is that right? 6640. 6640. Love it. Let's get our input. My input. Boop. And let's check it out. Let my input. Let my part 1 answer. Debug my part 1 answer. Run. Ooh. Attempt to subtract with overflow. Attempt to subtract with overflow. Oh, because I wrote 5 here. That's not, wait, no, that's, yeah, that's not 5. I just happened to do, I want, input.hands.length. Let hand count equals hands.length, and this can be hand count. That's what we wanted. There we go. Big number. Ooh, it's not the right answer. Your answer is too low. Okay. So let's make sure we're doing these orderings correctly. Because they gave us some tests. And so let's actually just write those as unit tests and make sure that we have everything set up right. So let's see. Function test. What are we testing as our first test case here? Let's go with the order. These and this. Okay, so let's do test 4 of kinds. And then we have, oh yeah, oops, I don't want to debug that. I want to do whoa, no, stop it. The developer tools needs access. I wasn't, okay. I didn't want to actually start the debugger. Cancel. Okay, phew. Use super star import everything. And so let a equal hand parse. And like the first hand is going to be this. Oh, and then we need a bid, but we can, the bid doesn't matter here. Let b equals assert that a is greater than b, assert equal a dot hand type is 4 of a kind, assert equal b dot hand type is 4 of a kind, run test. Cool. So that one worked great. And then let's copy this. Test, what are this? These are full houses. Test full house. And so we have this one and this one, and A is again bigger than it, and we have 3 of a kinds. Okay, no, that wasn't testing though, that was this. This was testing. Oh, there we go. Nice. Oh, yeah, well, they're not three of a kinds, they're full houses. Doesn't help if you don't write the test right. Okay, so those worked together. So you have to order these. Wait a sec. Where each hand wins an amount equal to its bid multiplied by its rank. So the weakest gets rank 1. Yeah, so that's your index in the sorted array. Oh, did I do this backwards? No, because I got the sample answer right. So there's no way, right? The multiplier is your index in the array where you're bigger, so you're going to be at the end if you're better. So the first thing is index 0. Oh, yeah. Your multiplier is just I plus 1. How did that get... Wow. Wow. Did they like purposely make it so it didn't matter which order you did that in to trip people up? Because that would be hilarious. Yeah, that's awesome. So I was just doing it completely backwards, and apparently the numbers work out so that doesn't matter for the sample. Oh, and then I don't need the hand count here because we're just using the index. Cool. Day 7, part 1. Oops, A7. That'll work for me. And part 2. To make things a little more interesting, the elf introduces one additional rule. Now J cards are jokers, wild cards that can act like whatever card would make the hand the strongest type possible. To balance this, J cards are now the weakest individual cards, even weaker than 2. The other cards stay in the same order. J cards can pretend to be whatever card is best for the purposes of determining hand type. For example, when there's 2 jokers here, that's now a 4 of a kind because you can make them queens. However, for the purpose of breaking ties between 2 hands of the same type, J is always treated as J, not the card it's pretending to be. So JKK is weaker than QQQ because J is weaker than Q. Now the above example goes very differently. Okay, so now I need to make different types that have different rules for part 2. So I think, again, we need to do parameterizing like we did before because things are going to be different. I don't think hand... Oh, man, it's like the whole thing needs to be different almost because hand needs to have a different hand type method, right? We need to go from hand to hand type differently to account for jokers. And the card order needs to be different. So there really is a lot different here. I think I just want to do mod part. I haven't done this yet, but we're just going to make a module for part 1 and we're going to make a module for part 2. And put all of at least the structures for them in their respective module. And now it's mad at me because all of this is private. Hub to the crate. Does that just do what I needed it to? No, the things are still not public to the crate, but I can change this. Oh man, I thought I was gonna just do pub to the, yeah. Add this to everything. Everything is public. Okay, what else needs to be made public? Oh yeah. That needs to be public. The bid needs to be public. Oh, clicking around the wrong spot. There we go. Part 1. Actually, this should all this whole module should just go in part 1. Items were found after the testing module. Okay, so I think the easiest way to fix that is to take it to its own file. Which I haven't done yet. So you can put modules in their own file. So if you just don't give it a body here, it assumes it's in a file. And so yeah, now we have our module with the tests for that over there. And our main is nice and easy. It just calls into some of the part 1 stuff. So that'll be a refactor. Everything should still work here. Nice. So let's make a commit for the refactor. And I think what I'm just going to do is I'm going to copy part 1 and just make a clone of it for part 2. And then what I need to do here is make the new module for part 2. But I think like the part 2 answer here is going to be the same. Blooming Code says just write a wrapper type as an exception for the Joker. A wrapper type around what? Around hand or card? Or around both? What I did before is I made something generic so that I could change the type inside of it. So I can definitely do that. If I need to make a different card, like do I make card and part 2 card and then make hand generic on the type of card? Because I can totally do that. And sorry for missing your message a few minutes ago, Bloom and Code. I need to get chat alerts to make more noise for me. I'd love to do some kind of wrapping instead of duping everything. So if you have an idea, let me know and we'll refactor into it for sure. Okay. So in part 2, why does it say this is never used? We never parse a hand? I feel like that's not true. Because we call input parse. And this calls hand parse. It doesn't think that's used either. Pretty sure I'm using it right here. Oh, part 2's never called. Got it. Let sample part 2 answer. Debug sample part 2 answer. Okay. So it's exactly the same at the moment because I haven't actually done the implementation. So let's do some easy stuff first. Since we just copy and pasted it, to change the order, all we have to do is make Jack the lowest card. Oh, I made a card that's a 1. There is no card that's a 1. You know what's funny? That's why Copilot didn't want to fill out the 1 for me, because it's like, yeah, there isn't a card that's a 1. You wrote ace. That's pretty hilarious. So we removed 1 and made Jack the lowest here. And actually, let's remove 1 for here too, because that's just wrong. We're never going to get a card that's a 1. Cool. Okay, so now we have our exception for Jack. So now let's actually think about the counts here. So we have our card count, and I guess, like, can I just do let Joker count is get cards that are a Jack, unwrap or 0. I don't think I need copied because, oh wow, I do need copied. Oh, but not cloned because it's copied, because it's a reference for things that implement copy. Yep. Okay, so I now know the Joker count. Do I want to remove? Is this actually remove? Do I remove the Jacks here? Option U size is not. Oh, because I'm removing it, I don't get a reference. That makes sense. Okay, so now 5 of a kind should still work, because ignoring Jokers, if everything else is the same, it's still a 5 out of kind. And now if there's any count where you add the Joker count and get 4, then that's a 4 of a kind. This one's more interesting though, because I can't just add it indiscriminately. This case is easy again, right? Because it's just we add the Joker count to however many the highest is, or whichever of them, and if any of them are three of a kind, this one triggers. But the full house one is interesting because they could be split across the two. And I'm not sure exactly what the best way to represent that is. Let's skip this for just a second. How should we split jokers here? But a few of these are easy, like the one pair is easy. You just again add the joker count. But these ones that split it are very interesting. Because let's think of a full house. So what are the options? If you had a pair and 3 jokers, you'd actually have a 5 of a kind. So that we can't have 3 jokers and hit this case. If you have 3 jokers and 1 other card, you have a 4 of a kind. So that's already also taken care of. So you can't have 3 jokers. You can have 2 jokers. And if you have 2 jokers and the 3 of a kind, you've got a 5 of a kind. So that means you can only have 1 joker that's relevant to a full house. Because if you have 4 jokers, it's a 5 of, if you have 5 jokers, it's a 5 of a kind. Less than or equal to 1, actually, because now you could have 0 if everything's a joker. That's also a 5 of a kind. It's like a special 5 of a kind, it feels like, but it's really not. And if you have 1 joke, if you have 4, you're automatically at a 4 of a kind, basically. Actually, no, if you have 4, you're already automatically at a 5 of a kind. If you have 3, you're automatically at a 4 of a kind. If you have 2 jokers, and you're thinking about a full house, and you have 2 jokers, you would have to split them, right? It would have to be 1 here and 1 here. Because you can't use them both. Because if you have 2 jokers and you want to use them together, not split, that means you have 3 that are the same, which means you actually have a 5 of a kind. So the only way that jokers matter here is if you split them. And I do see your comment now, Bloom and Code, about how you would do this differently. So let me think through the logic for full house here, and then I will read that. So I think I just want to, I think what I'm thinking is that there's one other way. There's one way to get a full house using 2 jokers. No. Okay. I've thought about this for a bit. And I think I'm ready to read your comment, Bloom and Code. If you make it so the card type enum is the one responsible for ordering the hand, you would make a joker card type, a joker card type and joker card. Then par 1 and part 2 would differ only by the way the hands are scored. Thinking about what you said. So if you made the card type enum is the one responsible for ordering the hand, you would make then a joker card type and joker card. Yep, I think I'm following you. I think that would be my hand and... Oh, no, hand, because I have hand type. No, but that's something different. Yeah, because these are the hand types. Yeah, so I think that would be my hand and my card. And I would need to have 1 of each that was special case. No, I think you're right. I would have to make the card enum the thing that does the ordering, because that is how... Because if we want the Jack Joker thing to matter, or hand type, not card type. A Joker hand... Oh, Joker hand type. Sure. That makes sense. Yeah. If hand type is the thing that we order. Because that's what I'm ordering anyways, right? And then I could have a method that's like Joker hand type instead of hand type. Oh, yeah. We'll refactor that at the end. I'm totally following you now. I like that a lot. Okay, so I want to figure out the 3 of a kind, or the full house thing, though. I want to be able to split these, but I don't know how that works because it could be one on each or it could be one total. Because you could have two pair. No, yeah, if you have two pairs, then you only have one extra card. This one's a little bit harder. I guess I could just enumerate all of the all the different Joker counts you could have here. This is the 0 Joker count. I can do the 1 Joker count. If you have 1 Joker count. Yep, okay, so let's do this. This is the 0 Joker count case. And then there's the 1 Joker. Oops. Sorry. 1 Joker count case where this is Joker count equals 1 and the reason I'm adding it, wait, does that work? Does that make sense? If you have 1 Joker, you have to find 1 card. Oh, I actually don't think Full House is implemented correctly. It's deceptively simple. I had this exact same hang up when I did it. Yeah, that is pretty simple, Bloom and Code, and I definitely don't think I would have come up with it right away on my own. But I actually think Full House... Oh, Full House kind of has a bug, but it's only present if there's a 5 of a kind, so it doesn't matter. Man, this is pretty nifty. Oh, wait, no. Is any 3 of a kind gonna count? No, because these aren't inclusive. You have the exact count of 3 and the exact count of 2. Oh, you had the exact thing when you did it for the Full House problem. It is deceptively simple. Oh, it's deceptively simple for the Full House. Okay. Well, it does seem a little deceptive to me, but maybe I just type these out and maybe I will come up with a deceptively simple case in a second. I think this works, but I'm not convinced this is the best way to do it. If you have 0, they just have to be a real Full House. If you have 1, then you can add it to the 3 and have it count that way. Really, there's 2 2s. No, this doesn't work because these 2 match the same thing. Yeah, this one doesn't work because these 2 match the same thing. So if you have 1 Joker, then I actually want where I want the same as 2 pair. If you have 1 Joker and 2 pair, you have a Full House. If there's 0 Jokers, you have to get a real Full House. If there's 1 Joker, you really need 2 pair. And then the 2 pair gets updated to a Full House. Okay, perfect. And if you have 2 Jokers, then you need to just have 1 that is 2 and 1 that's 1. Yeah. Because then these both get upgraded to a 3 and a 2 and you get the Full House. Okay, I think that feels right to me. Then 3 of a kind was easy. 2 pair. Okay, so now we have to think of 2 pair when you have Jokers. If you have 2 pair though, and you got a Joker, you have a Full House. So I actually think I don't need to worry about this at all. No, if you have a Joker and you don't do anything else, you're in 2 pair. If Joker count equals 1, or you actually have 2 pair. No, that's 1 pair. This goes down here. Sorry, I was getting confused. For one pair, either... Oh, well, no, I did the joker count thing here. Okay, so I don't need that. Sorry. I'm getting all mixed up. So 2 pair is another splitting thing, potentially. But let's think this through. So for 2 pair, it's 4 cards, and there's 2 of them that are 2. If you have 2 pair and a joker, you have a full house. That's this other case that I did up here. But what if you have you have a pair and then a joker? That's the other case. So you either get a real 2 pair, no joker case, or there's the 1 joker case, where if there's joker count equals 1 and you have a single pair, then you get upgraded to a 2 pair. I think that's right. Let's run this for the sample, 5905, 5905. Okay. Perfect. I think that's right, and it works for our sample. Let's plug it in for this. Let my part 2 answer debug my part 2 answer different big number, and it is different. Let's see. Yes, we got it. Okay. That is Advent of Code Day 7 Part 2. We're going to do some refactoring now, because I like not duplicating everything like we did here. Thank you, Bloom Code. Thank you for the congratulations. That one wasn't too bad. That was fun. I enjoyed this one. The jokers were interesting. Thinking through the jokers in part 2 was interesting. I'm not super duper happy with this. These feel like I just enumerated all the options, and it feels like there might be a more elegant way to do this, but I didn't really think of a better way. So yeah, not really 100% sure. But anyways, let's try to collapse these 2 down based on what Bloom Code was saying earlier. Then you can make a joker card type and a joker card. Yeah. So I think what we want to do here is this hand type in part 2 can be renamed to a joker hand type, I believe. Yep, and then where is that joker hand type? It's right down here. Perfect. Okay. And then I can make I could impl joker hand type. I'm just trying to think of how I want to do the conversion. I could just add a method to the hand that knows how to do a joker hand type. That might be the easiest. I was just trying to do it differently. Because hand right now is only, so I have joker hand type. Okay, so let's take joker hand type. And copy it to hand on part 1. We're gonna start combining a little bit. So then let's also take our joker hand type and put this in part 1 as a distinct thing. Awesome. And now I think what we want to do is, instead of actually ordering the hands, we're gonna take these orders away, which means we're not going to be able to sort down here, but that's okay, because these are everything can just sort on the hand type methods, or we can do the joker ones. Jack, joker, doesn't really matter which we call it. Okay, so now the part 1 stuff should still work fine. Hands dot sort by key of hand dot hand type. Oh, H. Oh, it's private. That's okay. We can make it not private. Public to the crates for hand type. I can also make this public to the crate for Joker hand type. Okay, and then the last thing that we need to do is we need to make a another type of card, I believe, for Joker card. But I don't want a... So is what you were saying, Bloom and Cube, if you're still there, that I could do like an actual wrapper where I would have Joker card, or not that, where I would have like struct Joker card, which just wraps a card. Yeah, that could work, right? Maybe. But then I need to implement the things for it, which I can do most of these. But I don't want to do partial order and order here, I don't feel like. But I still want them to implement those things. Hand type does the ordering. I need to scroll up and read chat again. You can make it so the hand type enum is the one responsible for ordering the hand. Then you would make a Joker hand type and Joker card. Then part 1 and part 2 would differ by the way the hands are sorted. Yep. But I think then would need to thread the different card through. And it almost feels like the best way to do that still is just to repeat the enum, unless I want to implement the partial order and order a little separately. And maybe I can do that. Maybe I can impl ord for Joker card. And it's like... But I don't want to handle the Jack case here specifically. Maybe make a game struct that holds the hand and bid. That game struct would implement order. Well, so that's what my hand struct is, right? Because my hand struct is the cards and bid, and then cards is just the array. So I could make a struct that like is just the array, if that's helpful, and make my hand that. That's what and I was ordering on hand before. Now we're ordering on hand type, which makes sense. We can have a hand type and a Joker hand type. Oh, but that doesn't even break. Oh, that's why I need a game struct. I think I see what you're saying. Because one thing that I lost here, I don't think I wanted that. One thing that I lost in this implementation is when I do the order in main just based off hand type, now we're not going to sort for the first card, second card bit, right? So we're actually only going to sort into the buckets, and we're not going to sort deeper than that. So I don't want to just sort by hand type. I do need it on... Yeah, then you can make a Joker game. But that feels really like I am duplicating everything. It doesn't really feel like anything then is shared besides maybe card. And I can pull out... No, card isn't shared because that has its own order. Yeah, it really feels like that's going to be duplicating just about everything again. And basically the same as just having my part 1 and part 2 modules. Because if we... Here, let's do this. Let me push up this code. And I can look at this on GitHub. Just so that we can see that version too. So if we look at what I have pushed up right now. Let's see how many structs I have in part 1. And let's enumerate them. Because I think we just duplicated basically all of them when we talked about how to restructure this, which is kind of fun. So we have hand, and we just talked about making making that hand game and then making a Joker game. So we talked about duplicating this. We did already duplicate card because we needed a different order, or at least I have one duplicated in mine. Yours might not have, but I did need to figure out how to do the order there. So I think it made the most sense to me to make a Joker card. And then we also made a Joker hand type. So the only thing we then didn't need to duplicate really is input, and I could have made it generic over the type of hand. But that doesn't seem like it would have been the most exciting, to be honest. I kind of feel like that's not that different, but you are saying something different in chat, so let me read that. The Joker would only have to deal with the Joker exception and use the standard version of the rest of the logic. And you just mean for card, right? Which is totally fair, but the card doesn't... The only logic the card has on its own is the from implementation and these derives. And the ordering of the derives is important for the order, right? So if we made the card copy, partial order and order was kind of free if we just put Jack at the beginning. And you're right, we have to duplicate this logic, the from card. But I actually couldn't figure out an easy way to do just the Jack logic here, because that's what we're kind of doing here, right? So if I have my card, or if I have my Joker card, and I'm trying to impl ord for Joker card, do I just need to check both of them for being a Joker and rate them both and rate it low if it is? So like I guess I can do if self dot 0 equals a Joker, or a Jack in this case, because that's what it is. Anything is greater. I just need to figure out what the order is. 5 compared to 10 says 5 is less than 10. So this is going to be less because I am less. And then if other.0 is a Jack, it's greater, and then fallback. So I guess that's what you were saying. That's not as bad as I thought it was going to be. That's what I was thinking. Yeah, this was actually, I for some reason this logic seemed a lot harder than it ended up being. So let's at least follow this through, right? Because we're pretty close here. So now I can just impl partial order for Joker and just wrap it in sum. Okay. So now we have hand has a hand type, and then there's Joker hand type. Actually, Joker hand type, that's just a direct clone. Do I need... I don't think I need Joker hand type. I don't think that needs to exist. All of these can just be hand type because I didn't change this. Okay, so that's one more thing that didn't need to change. Cool. We need a method that determines it differently, but we don't need a different type. Yeah, awesome. You agree. Okay. Okay. There we go. That's better. Now we have hand type and Joker hand type, and they both return the same type. And we have hand and do I need hand? Yeah, I think I want hand to be generic on a card type. And then impl on T for any, and this can be card type. I just like naming things like that. So we're implementing hand for any card type. Cool. Thought there was did I not write a parse for hand that's gonna be a little upset here? Yeah, this can't be happy with me because that doesn't do what I said it was gonna do. Okay, I think we just haven't got there yet. Input of card type, hand of card type, because there's going to be an error up top more in a second once I get there. Impl for card type, input of card type. Yeah, okay, we got some more errors to deal with. Let's go up to the top. Yeah, okay, so this is card. I really want this to be card type. So then where card type implements from character. Oh, and it also implements debug so that we can unwrap it. What? Standard, yeah, okay, interesting. Standard format debug. It just assumed I meant the macro, which is kind of funny. Okay, cool. So we got that generic there. This is on card type, whatever kind of card we have. The method entry, because card type needs to be equal and hash. Expected trait found derived macro, so this wants to be standard hash. Cool. Awesome. This is the same thing. This is card type. This one actually might need to go in a separate thing. Yeah, okay, cool. This is gonna go in a separate impl. Yeah, because what we're gonna do is we're gonna close the generic impl and we're gonna do impl card type, basically the same thing again. Oh, actually, no, we're not gonna make this generic. We're gonna say that this time this is only for a Joker card. So this is a Joker card. And then so we remove Joker card wrapping Jack. Perfect. Okay, awesome. So now we have all that. What is going on down at the bottom here? So parsing this. Oh, okay, yeah, because my Joker card does not implement the from nicely. So impl from character for Joker card and just do the parsing. The trait card type from character. Oh, I just have to tell it this. Yes, where card type implements from character. And it also needs debug. Standard format debug. Does it need more? Yeah, it needs all of the things. Plus equals plus standard hash. Is that all? Nice. Okay. This one is a hand of a card. This one is also a hand of card. We're just doing it for the those were just testing the simple ones. Okay, so then part 2 as a module, I think I can just delete. I'm gonna delete part 1 eventually as well, but not yet. This is an input of a card. Qualify it as part 1 card. Actually, that's okay. I wouldn't do that, but that's okay. So this is actually still going to be from part 1. Get the input, but now this is of a Joker card. Can't find Joker card. Joker card. Pub crate. Import it. Okay, there we go. Oh yes, because we need to sort by. Oh, actually no, I do want sort by hand. Yeah. I do want sort again because that was important for doing the card ordering. But I think I can make these implement order. I just don't have them implementing order right now. Impl card type. Yep, we have an impl on card type where that implements order. And then we want to implement order for hand of card type. We do the comparing of hand, and then we compare with cards, and cards are orderable, so that should work. We need to implement partial order. That makes sense. Impl partial order. No, this is actually ord still. Hand type exists in reference, but its trait bounds were not satisfied. What do you mean by that one? Oh, it needs to be from character debug hash. Yeah, okay. Kind of just like, yeah. All of these things. Yay! Okay, we have one error though. Where's our error? Can't move out of the reference. Yeah, but what if it's just copy? Yay! And then this is also copy. Yay for trait bounds everywhere. Except now, yeah, I was gonna say, I was wondering if, yeah, because this needs copy. We're gonna have to add this to a few more places. I'm not even sure if my Jack card or Joker card. Nope, I did add copy and clone on it. Perfect. Okay, awesome. So let's actually delete this. We shouldn't need the part 2 file anymore. And let's also, can I unmove this? Oh wait, now you won't give me the option to put it back here. You moved it fine, but you don't want to unmove it fine. Oh, that's annoying. Okay, but let's actually just take all of this and put it here. Just put it directly in the crate body. And then every time we talk about part 1, just delete it. There we go. What are you so mad about? Items were found after testing module. Oh, sure. Yeah, that's fine. Can you fix it for me? No? Okay. Okay. Cargo test. Ooh, it failed. What'd you fail on? It panicked. Why are we panicking? Assertion failed. Uh-oh. A is greater than B. You can simplify the hand type logic into a match based on the max count and the number of card variants. The hand type logic with the max based on the max count and number of card variants. Ooh, I need to look at that in a second, but first I have a test that's just wrong that I need to think about. And this is for the normal cards, so I'm surprised. Because hand type for a normal card really shouldn't have changed here. So I'm not sure what this is mad about in these tests. Because that should be using standard card. And standard card still has the right order there. And hand type's order never changed. So I wonder what I did wrong here. And do they actually... Oh, I know. The hand types are equal, not greater than. The hands, though, which are comparable still, are going to be different. That was just bad test writing. There we go. Okay. Part 1, this can be deleted now because we didn't actually break that out. And part 2, okay, we can just cargo run it, get the thing, and then I think this is the same number, but let's see if Advent of Code agrees. Return to day 7. No, it's a different one. Awesome. Oh, is my part 1 still the same? Wait. That one just didn't copy, but I don't actually think it is. 473? Oh no, 473. Okay. Yep. Part 1 is the same. Part 2 is not working right now. So we do have a bug in part 2. Awesome. Okay, so let's take a look at this. Part 2 is you're going to parse with the Joker card, sort the hands. Oh, because sorting the hands here, I see. Yep. I need to make these different. You can simplify the hand type logic into a match based on max count and number of card variants. Yeah, that's still not the bug that I just found, but that's okay. This actually, so I'm gonna, for, you have a normal card, you implement order by calling hand count. This is better. Oh, I like this. But if you have a Joker card, we don't have to be generic here. Just define it for the 2 things that it does have. Now you call Joker hand type. And actually, no, let's do this in a different spot. We're going to do basically the same thing, but we're going to do it in a different spot. I think. No, I do like it here, actually. Nope, we're going to do this. For, they're just going to have different order methods. Okay, there we go. Oh. The method compare exists for reference, but its trait bounds were not satisfied. Oh yeah, because I just need to do for card. Oh, actually no, let's do this. For card type where hand at card is order. Oh, card type. Oh, yep. Nice. We implement partial order for anywhere that implements order. This is very like circular logic in how those are defined, but I love it. Okay. 85825? No, 917. Uh-oh. Still not the right number. Okay. And our Joker card is if I'm a jack, the other thing's less than me. If the other thing's than a jack, I'm greater than it. Oh. There was a Copilot threw in a freaking reverse on me. That's still not the right answer, though. 5904. It's the sample answer. Sample 5905. Okay, so that's the right sample. That's not the right big answer, though. Yeah. So if neither one's a jack, where the ordering rules are special, we just fall back to normal ordering, which should work. That's interesting. So where's our bug? Actually, I want to do this a little differently too. The only thing that's going to be generic is the parse, and then we'll do impl hand card implements card type or hand type, because then I can actually have this also implement hand type and have it be named the same, and then this can just be hand type. Could even make a trait for hand type if I needed to, but we're not going to do that right yet. But that shouldn't change the number at all. That's just pushing code around. because 917 is the end we're looking for there. That's interesting. I don't know what we changed that I think would have done that. Because here's our hand type for hands that have Joker cards. You do the counts, you remove the Joker / jacks, whatever. And then you do all of the logic. But this is the same logic I was doing before, so I don't think I changed that at all. And then this is still the right order for card, because Joker card has Jack special cased out. The parsing for card is still the same. The parsing for Joker card just calls down to it. Hand type is defined in the right order. You can simplify with a match based on the max count and the number of card variants. Oh yeah, I think I'm finally understanding that, but that's not the bug I'm running into, which makes this a bit interesting. So we're just sorting the hands, but we should just be able to sort the hands because I have a Joker card now. So like this knows how to do order correctly, because it does it differently depending on the case. If you have a card, it does it differently than if you have a Joker card. They're both the same though. They both just call hand type. This one's interesting. I'm not seeing. You need to check if both self and other are jacks before checking individually. Oh, because they could be equal. For some reason, I was thinking that it didn't matter in that case, but it totally does matter because equal is a different comparison than this. Yep. So if that's a jack and the other's a jack, then you do equal. Yeah, Copilot just knew what to do. I just needed to give Copilot a chance. Yep, there you go. That's the answer we were looking for. Well, not what I copied to my clipboard. But there we go. Okay. Thank you, Bloom and Code. You were very helpful in all of these refactors today. Refactor down to less types and more generics. And we're like really close. There's one more thing that I think I want to do. I think I want to make a trait for like hand type, like the thing like this where we implement and can do this hand type. So like maybe we just make a scorable hand, or just a trait. Yeah, scorable is fine. And it just returns a hand type. So then we're going to impl scorable for Joker. No E in scorable, apparently. That's how I decided to type it. And then the other one's up here, I bet. Yep. Impl scorable for this one. And then what we can do up here is we can do an impl on card type is order where hand at card type implements our scorable trait. And then we don't need this implementation because they're the same. Oh, and I think I need a few more things there, but that's okay. Where card type is equal and hash and copy. What else do we need? Order, and standard format debug. And Bloom and Code, happy to be here. I have to go to bed. Definitely take care of yourself and get some sleep. Thanks for coming and hanging out. I hope to see you around some other time. Thank you for the follow. I appreciate it. And one more time, thanks again for all your help this evening. It was very helpful. And yeah, we kept that the same. Awesome. Okay. I get that notification twice, but it's fun. Add scoreable trait. Awesome. Okay, so now we're pretty good and factored out. I like that. And I think we are gonna call it a day for Advent of Code day 7. Oh, let's get that pushed up. And there we go. Now that that's pushed up, I think that's about all I've got in store for today. Join me tomorrow for day 8 of Advent of Code. We will keep doing these every day as long as we can. I've made it through day 15 in previous years, but I really want to finish all 25 this year. So fingers crossed we can do it. If you want to find more from me, check out my blog at CoreyJA.com or CoreyJA on GitHub, Twitch, and YouTube. So find me on all the channels. And until next time, I will see everyone online. Thanks, team. See you later. Bye.